Continuation. Activation of peripheral NK cells. Activated natural killer T cells secrete a broad range of cytokines such as Th17, Th1, Th2, and TGF-beta, IL-2, and IL-10 respectively among a group of innate lymphoid cells and myeloid cells. Only NKT cells respond to type 1 IFN other than IL-33, IL-23, and IL-1, IL-18, and IL-12. In the peripheral lymph nodes, NKTs produce IL-17 as a result of IL-23 and IL-1 production by dendritic cells. So NKT cells can be stimulated by the interaction of their surface molecule TCRs with the glycolipids presented by the class 1 MHC molecule bearing antigen presenting cells. Those NKT cells which are stimulated by the glycopeptide provide different immune response than those NKT cells activated by the cytokine production of other immune cells. The role of NKT cells in pulmonary immunity. Mucosal sites are populated with innate and innate-like T cells, NKT, which are in continuous exposure to antigens. NKT cells play a dual role in modulating immune response and inflammatory responses. Asthma is a complex disease with disabled inflammatory respiratory function, and its most common form is allergic asthma. Non-allergic and allergic asthma is characterized by common features of disease such as airway hypersensitivity, AHR, infiltration of eosinophils, enhanced IgE levels, Th2 polarized response, and mucus hypertension. So COPD or chronic obstructive pulmonary disease is characterized by airway limitation as a result of chronic inflammation. Then researchers revealed the increased number of NKT cells, whether invariant or variant type in lungs of patients with COPD, chronic obstructive pulmonary disease. On infection with Sendai virus, independent of adaptive immune response, NKT cells leads to macrophage-assisted IL-17 cytokine production, which further resulted in stimulation of mucus production and AHR. NKT cells have defensive role in protecting lungs from respiratory respirations. Pulmonary NKT cells helps in antigen clearance based on the activation of dendritic cells and further stimulation of cytotoxic CD8 plus T lymphocytes and NK cells. For instance, in RSV, respiratory syncytial virus infection, pulmonary NKT cells leads to the clearance of infection through alpha glacier activation and antiviral T cells and then their other immune cells. On influenza virus infection, more specifically IAV, influenza A virus mediated pulmonary disease, CD1D dependent MNKT cell activation leads to adaptive immune responses. On H3N3 influenza virus infection, NKT mediated IL-22 and IFN gamma production and specific adaptive CD8 plus T lymphocytes are promoted, which protects against influenza virus infection. So iNKT cells produce IL-17 and IL-22 abundantly in lung mucosal membrane on Algae-Galser stimulation. Mucosal membrane, when infected with virus, production of IL-33 cytokines in abundance along with IFN gamma and TNF alpha production leads to stimulation of MNKT cells. On activation, this natural killer T cells leads to production of IL-22, IL-13, TFN alpha and perforins for the clearance of infecting agents. So antigen presenting cells stimulating CD8 plus T cells directly through the selection of cytokines like IL-12, IL-4 and IL-13 and NKT cells by IL-12 cytokine production. NKT cells, macrophages and stimulated adaptive immune cells CD8 plus T cells secrete IL-13 cytokine, which leads to the polarization of macrophage, AHR, etc. at the site of infection within lamina propria of lungs. NKT-mediated IFN, gamma and IL-17 cytokine production and invasion of neutrophils and other lymphocytes leads to clearance of S. pneumoniae. A plethora of publications revealed the role of NKT cells mediated clearance of Mycobacterium infection MNKT cells provide protection against MTD and other mycobacterium infection in an IFN gamma dependent pathway. MNKT cells are activated by alpha MNASR glycolipids, unlike alpha GLASR by INKT, which via mRI molecule bind to the V alpha 19 7/2I on the MKT surface. MNKT. So conventional invariant NKT interacts to CD1D presented alpha glacial glycolipids on APCs via V alpha 14 24I receptor. Activation of iNKT cells relies on IL-12 and IL-18 cytokine production. Even in the absence of TCR activation, virus and bacteria induce robust IL-12 response by APC-DC. iNKT cells produce IL-17, IL-22 in abundance amount in the lung mucosa membrane on alpha glacial stimulation. Then antigen presenting cells represent toll-like receptors on the surface to recognize PAMP or microbial cell wall. The dendritic cells or other antigen presenting cells represent alpha MALSR as a glycolipid instead of alpha GLASR via MR1 MHC related molecule 1 after binding with V alpha 19 7/2I. These mucosal NKTs, MNKTs, after bacterial infection get stimulated to secrete IL-13 to further activate the disease along with the production of IFN gamma, IL-22 and IL-17, further producing Th17 cytokines. Lung lamina propria, lung lumen bacteria, toll-like receptor MR1, alpha MALSA, MNKT cells. Intestinal NKT cells. Type 1 NKT cells involve both mucosal associated invariant T cells and invariant NKT cells, iNKT, while negligible MNKT are there in intestinal tissues. MAIT is expressed T cell receptors with invariant V alpha 19 chain, while V alpha 24 chain is expressed in iNKT cells. Few publications suggest that NKT, mucosal NKT cells are virtually absent in intestinal mucosa membrane, but recent papers revealed the role of MNKT cells in intestinal mucosa immunity. So iNKT express T cell receptors which bind with the mRI MHC related molecule 1 representing glycolipids. So MR1 is a class 1 type MHC molecule and highly conserved in mammalian system. The NKT development is dependent on the bone marrow derived cells expressing mRI. The NKT cells are directed towards the mRI molecule presenting the microbial glycolipids and therefore specifically accumulated in the intestinal lamina propria. CD1D expressing antigen presenting cells can be professional like B cells, macrophages, etc., or non-professional like intestinal epithelial cells presenting antigen to both NKT and other lymphocytes in the intestine. So ligation of CD1 on intestinal epithelial cells control the inflammation and maintain the homeostasis of mucosal tissue. CD1D restricted for MR1 restricted NKT cells are activated by the glycolipids known as alpha GLASR. The CD1D or MR1 and alpha GLASR forms a complex recognized by the TCR activated by the glycolipids known as alpha GLASR. The CD1 or MRI1 and the alpha GLASR forms a complex recognized by the TCR on the surface of NKT cells. Hence, the stimulation of antigen presenting cells via toll-like receptor ligands leads to enhanced activity of NKT cells to recognize secreting higher IFN alpha. Therefore, the role of TCRs and CD1 surface markers of NKT confirms the antimicrobial role of these cells and ensure enhanced mucosal immune response. Also, on bacterial infection, the immune cells, especially antigen presenting cells, expressing toll-like receptors and PAMP recognize microorganisms and get stimulated. On stimulation, this TC leads to activation of iNKT cells by representing alpha glacial glycolipids to CD1D receptor to V alpha 14 to 4I. T cell receptor on iNKT cells DCs through the IL-12 and IL-18 production will further enhance the antimicrobial activity of iNKT cells and also activate adaptive immune cells like CD8 plus and CD4 plus T lymphocytes. In return, iNKT cells secrete IL-13, IL-17 and IFN gamma cytokines to activate disease and to stimulate myeloid linkage related IB lymphocytes. Now summary. Question still needs to be answered regarding the entry or homing of NK cells to specific tissues, regulation of diverse function of NK cells and source of NK cells, precursors, etc. Still, group 1 innate lymphoid cells or conventional NK cells play an important role in controlling and protecting against several infections including parasitic, fungal, bacterial or viral. When we talk about homing of NK cells in mucosal tissue, we must understand the developmental stages of NK cells when they gain entry to mucosal tissue. The lamina propria of lung cells represents mature phenotype of NK cells. The NK cells in secondary lymphoid tissues when interacts with antigen presenting cells. The APCs employ the address of immature precursor NK cells and program them to become tissue specific NK cells such as female reproductive tract or gut mucosal NK cells. During infection with pathogens like virus, parasites or bacteria, NK cells of the mucosal tissue can control the infection at early stages by the production of IFN gamma. Additional control is provided by the peripheral NK cells recruitment and expansion of resistant mucosal NK cells in response to inflammation and production of chemokines IFN gamma, IL-12 and IFN alpha beta. NKT cells are natural killer cells, killer T cells mainly found in organs such as bone marrow, liver and spleen, either in variant or mucosal NKT state within the lamina propria. GATA3, TBET are conserved transcription factors of NKT development lineage. On activation abroad of cytokines like Th70, Th1, TGF beta, IL-10R, etc. are secreted at the mucosal secretion site. Mucosal reaction site. NKT interacts with class 1 MHC like molecule presented glycolipids of antigen presenting cells through TCRs on their cell surface. NKT cells also play an important role in disease like asthma, especially allergy asthma and COPD, which are respiratory or lung associated disease. So NKT cells activate antigen presenting cells and further stimulate adaptive immune cells like CD8 plus T lymphocytes and innate immune cells such as NK cells at the site of mucosal reaction to clear pathogens. NKT cells encounter and help in the clearance of several viruses infecting the lung. On viral infection at the mucosal sites, stimulated NKT cells interacts and further activates antigen presenting cells through alpha glycia presentation and leads to IL-17, IL-22 and IFN gamma cytokine production. Influenza virus infections can be resisted by NKT cells. Several bacterial infections such as M. tuberculosis, M. pneumonias, etc. can be cleared through NKT-mediated immune response. NKT cells play an important immunoregulatory role in regulating the immune response on viral or bacterial infection at different mucosal sites. In lung mucosal sites, viral infection leads to disease and NKT cells stimulating and production of cytokines like IL-22, IL-13 for foreign and TNF alpha. On the other hand, mucosal immunity response against bacterial infection leads to production of cytokines such as IFN alpha, IL-22, IL-17, Th17, etc. In intestinal mucosal immune system, IL-12, 18, 13 and 17, IFN gamma cytokines are produced as a result of interplay of immune response between different immune cells of both innate and adaptive immunity. Thank you for listening.